I'm Anil Kumar. This is part 2 on applications. We'll discuss optimization. All the examples in part 2 I have taken which are related to distance. The first question here is, find the point on the parabola 2y equals to x squared that is closest to the point minus 4, 1. So let's sketch and then figure it out. This parabola opens up and this point is also upwards. So let me draw the parabola. Let's say the parabola is kind of like this. Okay. And let us consider a point which is, let's say, minus 4 and 1, which will be on this side. So let this be the point which is minus 4 and 1. We want to find a point on the parabola which is closest to that point. So could be, let's say, could be some point here or wherever, right? We are not very sure of this. So let this be the point. So for the time being, let's keep this point as variable. Let me write down the equation of the parabola first. We are given equation as 2y equals to x squared, which could be written as y equals to x squared over 2. So any point on this general point, we can say the x value is x, then the y value will be x squared over 2. Correct? So that becomes a general point. Let's call this point as P and let this point be Q to us. So we are given point Q, which is minus 4, 1. And a general point P can be defined as x and x squared by 2. Now in this series, all the questions are distance related. Distance, as you know, can be found by square root of x minus x1 whole square plus y minus y1 whole square root. So that is the general formula. So we'll just apply this general formula and then to find the closest point, we'll find the first derivative. So we can say distance is equal to, in our case, x minus 4, which is x plus 4 whole square, plus the y value is x square over 2 minus 1 whole square root. Now, to find the minimum, let's differentiate both sides with x. So we get dd over dx as equal to derivative of this, which is 1 over 2 square root of all this, which is x plus 4 whole square plus x square over 2 minus 1 whole square. On the top, we have to write derivative of this function, inside function, which is 2 times x plus 4 plus 2 times x squared by 2 minus 1 times derivative of inside function, which is 2x over 2, right? So that becomes the derivative. And for minimum, distance closest means minimum, that should be equal to 0. So we'll find the critical number, equating this to 0. 0 really means that the numerator should be 0, correct? So we get our equation, which is, let me rewrite the numerator now, which should be 2 times x plus 4 plus 2 times, this is x squared over 2 minus 1. 2 and 2 cancel, we are left with x, that should be equal to 0. So we have to solve this equation for x to get the answer, correct? So let's take it to the right side and further solve. So let's open this bracket. So we can actually divide by 2. So when I divide by 2, we can get x plus 4. So I'm dividing by 2. That means I'll cancel these 2's. Is it okay? Dividing by 2, both sides. We are left with x plus 4 here. On this side, we are left with x squared over 2 times x, which is x cube. So we have plus x cube over 2, and this is minus x, and we are equating this to 0. X minus x is 0, so we get 4 plus x cube over 2 as equal to 0. Now we can take this to the right side, so we have x cube equals to minus 8, and that really means that x is equal to minus 2, right? So at x equals to minus 2, we get a point, the critical number, which should give us the minimum distance, correct? Now if x is minus 2, what is y? So we can write y equals to minus 2 whole square by 2, which is 4 over 2 as 2, and therefore the point P will be minus 2, 2. Now in this particular case, how do we prove that this is the closest point? That's the second thing which we need to do. Now for that, what you can do is you can take any other point close by and then show that it is longer than this. This is what you could do. But I'll leave it here for time being, assuming that this is the closest point, right? So we get our answer, which is minus 2, 2. So let's move on further and do the next question. The next question here is, a cable television company is laying a cable in an area with underground utilities. 2 subdivisions are located on the opposite side of a creek, which is 100 meters wide. The company has to connect point P and Q with cable, where Q is on the north block, this is north, on the north block 200 meters east of P. It costs $40 per meter to lay cable underground and $80 per meter to lay cable underwater. What is the least expensive way to lay the cable? So let's sketch. Let's say that's the creek for us. So I'll make a small sketch here. Point P is given to us on one side, and on the north side we have point Q. So as per the given information, we can say that we have point P here and point Q somewhere there. We are also given that this creek is 100 meter wide. So this distance is 100 meters. And it is 1200 meters east. So that distance total is 1200 meters. We have to lay a cable from P to Q. So one way could be go direct, right? That could be one way. One way could be go somewhere here and then go underwater. That could be the other way. The third way could be you could go like this and then kind of like this. So these are different ways in which you can lay the cable. Let's figure out what is the minimum cost. Now let us say this is the point where this is the opposite end, and let this be the point from where we do underwater. Now in this particular case, if I assume PS distance to be x, then SR distance will be 1200 minus x, correct? Since total is 1200. Now let's figure out the cost. Cost rate is given to us as underwater rate is 80 meters. So underwater this will be at $80 per meter, and here it is half the cost, which is at the rate of 40 per meter. Correct? So the cost will be distance into the rate, right? So distance into rate is the cost. So we can write cost is equal to, from P to S, it will be 40 times X plus from S to Q, it is going to be 80 times S to Q. Now how much is SQ? To find the distance SQ, we can actually apply the Pythagorean theorem. It will be square root of this square, which is 1200 minus x whole square, plus that square, which is 100. Perfect. So that becomes the cost function. Is it okay? So QS is the hypotenuse of a right triangle where the sides are 100 and 1200 minus x. So that will be the length SQ. Correct. As far as the x value is concerned, x could be 0 and could be up to 1200. So that is the boundary condition for x. Now to find, so this is our variable now in x. To find the minimum cost, let's find its derivative. So it is 40 here, plus 80 times derivative of inside function, which is, this derivative will be minus, because of this, I'm writing minus 2 times 1200 minus x, and derivative for 100 is 0. So that comes in the numerator. In the denominator, we have 2 times square root of all this, which is 1200 minus x whole square plus 100 square, right? So let me write 2 more zeros. Now for critical number, it should be 0. So I'm cutting down on steps. I have very limited space. So that becomes equals to 0 for critical number. So this is for critical number. Now we have to equate this to 0. So what we can do is, we can take these terms on one side, multiply, and get our answer. Correct? So that is the way we should be doing. Now in this particular case, we have minus here. So we could take it to the other side. We could simplify this also. 40 we can divide into 80. So let me write this as, this divided by this is 40, correct? So we get divide everything by 40, so you get 1 here. Okay, and then we'll cross multiply. So once we cross multiply, this is minus, I'm taking it to the other side, so I can write this as 2 times 1200 minus x equals 2. Now this is 40 and 40, 1, right? So that gets multiplied with this, and we get square root of all this, which is 1200 minus x whole square plus 100 times 100. Is that clear? So first step, I took this on the right side, then I cross multiplied and also cancelled 40s. Okay, so this is what we get. Now to find, let's square both sides. Let's square both sides. So if I square both sides, I'll get rid of the square root. So what we get here is 4 times 1200 minus x whole square equals to 1200 minus x whole square plus 100 times 100. So we could simplify this now, bringing it on that side, so it becomes simpler. Let's solve this. So it is 3 times 1200 minus x whole square equals to 100 times 100. So if I square root it, let me take it to the right side now to do the rest. Okay, so we get 1200 minus x whole square equals to 100 times 100 divided by 3. And now we can square root this, and so we have 1200 minus x equals to square root of 100 times 100 over 3. So let's calculate this value. So we need square root of 100 divided by 3 equals to, we'll round this number. So we have 57 point, let's say 74. Is it okay? Now what is x equals to? So taking x to this side and taking away that number, right? So we get our value of x. So we have 1200 minus 57, or let's say, okay, it doesn't matter, equals to x. So we have 1200 take away 57.74 is equal to, sorry, I deleted. Okay, so I mean, so we got 1142 So 60, 1140, that makes sense. So it is equals to 1142, right? So that becomes the value of x in our case. X is 1142 and the other side is, of course, we had 57, or we could round it to, so we are rounding it to 1142. So what we get here is that the cost for us will be, for x equals to 1142, we could have the minimum cost. Is it okay? Now that's what we get. Now, if you analyze, that is to say, if you say these two conditions, that is to say, if x is 0, then what is the cost? So I'd like you to find the cost. I'd like you to find the cost when x is 0. I'd like you to find the cost when x is 1200. And also the cost when x is 1142, right? So use calculator, figure out all these three different costs, compare them. So when you compare, you'll find that this is lowest. So that is the minimum cost. Is it okay? So we'll conclude here rather than my calculating. So we'll calculate, and then you need to confirm this. And then we say that for x meters, which is 1142 meters over the ground, right? So that is over the ground. And the rest, which is 58 meters underwater, will result into minimum cost. Is it okay? But remember to do this calculation just to confirm. That is extremely important. So I hope that makes sense. So let's move on and do the next question of this exam review. Here is a very important question from test point of view. The question is, two towns A and B are 4 kilometer and 6 kilometer respectively from an old railroad line that has been made into a bike trail. Points C and D on the trail are the closest points to the towns respectively. These points are 8 kilometers apart. Where should a rest stop be built to minimize the length of the new trail that must be built from both towns to the rest stop? So let's first sketch and then figure out the equations to work with. So what we're given here is we are given two towns A and B, right? Let's say this is A and B, and these towns are 4 kilometer and 6 kilometer from the road. So this distance here is 4 kilometers and this distance here is 6 kilometers. So what we have here is towns A and B, let's say A and B, and these 2 points are C and D. The distance between these towns is given to us as 8 kilometers. So all units are in kilometers. What we need to do is to make a trail which will be which could be, let me use another color here. So let's say that's the trail, something like this. So that the cost of this trail is minimum, or the distance between, let me call this point as E, AE plus EB is minimum. That is the question for you. So I hope it is well understood. And now you can actually pause the video, answer the question, and then look into my suggestions. Okay. Now let's see how to solve such a question. So basically, what we need to do is we have to minimize the distance AE plus EB. So that is a question for us basically. So minimize AE plus EB. So what is AE? To find A, let me say this is x. In that case, the other will be 8 minus x. We'll use Pythagorean theorem. So we can say this is, or we can say what we need to do, let's say y equals to, we'll minimize this distance y, which is 4 square plus x square square root, right? So square root of 4 square plus x square plus EB will be square root of 8 minus x whole square plus 6 square. That is what we need to minimize. So first derivatives, we can say first derivative will be, now this square root function, you know, it is 1 over 2 square root of everything which you have there times derivative, which is 2x, plus again 2 times square root of 8 minus x whole square plus 6 square, and derivative of this, which is 2 times 8 minus x. So that becomes the derivative, and as we did in previous questions, will equate to 0 to get the critical number. Perfect. You could simplify this, cancelling these 2's. Now what? So now we can just equate them. Basically, we can take this common denominator, multiply, and solve for x. That's what we can do now. So we basically cross multiply, so we get x times all this, square root of 8 minus x whole square plus 6 square, I could have written 36, plus that term, which is 8 minus x times square of this, square root of 4 square plus x square, equals to 0. Now, in this equation, we have minus x term also. So we can actually take it to the other side and then square both sides. We could do that. So let me rewrite this as x times square root of 8 minus x whole square plus 6 square equals to. So when I take it to the other side, I'll write this as x minus 8. Does it make sense to you? So that is negative of this, right? Times square root of 4 square plus x square. Now we can square both sides, getting rid of these square roots. So we get x times 8 minus x whole square plus 6 square, right? Everything is in brackets, equals to, when you square, that becomes square. This also becomes square. And we get 4 square plus x square. Perfect. Now, you know, a lot of calculations are involved in these questions, and normally you need one full page to solve. I'll try to squeeze it in. So we have x squared times all this. We have x, and here we have a square with this, x squared times this. So what you notice here is that we could simplify a bit more. Let's open this bracket. So we have x squared times 8 minus x whole square plus 6 square times x square, and we have here x minus 8 whole square times 4 square plus x square times x minus 8 whole square, correct? Purposely I am not expanding square terms since they cancel. Do you see this? This term cancels with that term. So we are now working with only the center part, okay? So let's take it on this side. It will become more clear. Both sides are squared. So what we will do now is we'll square root them. So this is a good technique to solve without getting into calculator and big calculations. So now when you square root them, you get 6x on the left side. Do you see that? And when you square root this term, you get x minus 8 times 4. Does it make sense to you? You get x minus 8 times 4. Now, one thing is very critical to understand in these things, and that is, whenever you square root, you actually get plus or minus. We get both. Because whenever you square root, you actually get an absolute value. Now, this is a critical step. So you get actually both plus and minus. Does it make sense to you? So basically, we have two equations here to work with. Okay. So we could write this one as 6x equals to, I'm using minus value first, minus 4 times x minus 8, right? We'll solve with this. So we have 6x, when you open this, bring 4 to this side, plus 4x equals to 8 times 4 as 32, right? So that is 10x equals to 32, or x is equals to 3.2. Do you see that? Now that is one valid solution. The other one which you get is, if I use the plus value, see what happens. We get 6x equals to 4x minus 32, correct? Now in this case, we get invalid answer. Since this is negative, do you see that? Since it is so not valid. Now many times you can get stuck if you do these kinds of calculations, and if you don't realize that square root means plus and minus. You get my point, right? So basically, you have to take care of that. So that's what I mean. So x is equals to 3.2. So this distance 3.2. The other distance should be 8 minus 3.2. So you could now write that you are 3.2 away from C. That is your answer. Now, second part is, of course, how do you show that this is minimum distance? Again, I'll leave that as an exercise. You find the value for x equals to 0 and x equals to 8. So those are your boundary conditions, okay? You will find that this is more than the value calculated by x equals to 3.2. And therefore, the answer is, it has to be 3.2 kilometers from C. Perfect. So we get our answer as it is 3.2 kilometers away from C. Perfect. So that is how you have to do. But don't forget to calculate values for C equals to, because for x equals to, x is between 0 and 12, 8, right? So you have to calculate these two values to verify, okay? So you need to verify this answer, okay? We are almost at the end. The question here is, a motorist starts braking for a stop sign. After t seconds, the distance in meters from the front of the car to the stop sign is given by s of t equals to 62 minus 16t plus t square. There are two parts to this question. The first one is, how far was the front of the car from the sign when the driver started braking? The second one is, does the car go beyond the stop sign before stopping? Correct? So this is a straightforward question. When we want to know the initial position, we can substitute 0 here. So just find what s of 0 is, which gives us 62 minus 16 times 0 plus 0 square, and so it is 62 meters. Since the units are in meters, so the car is 62 meters away when it started braking, applying brakes. Part B is, does the car go beyond the stop sign before stopping? Now, to answer this question, we have to figure out when will the car stop. So car will stop when velocity is 0, right? So stop means what? Stop means velocity is 0, correct? To find velocity, we need to find the derivative. So we are given displacement or position vector, position equation as 62 minus 16t plus t square. Derivative of this is actually the velocity. So the derivative is minus 16 plus 2t. To stop, that has to be 0, right? So 0 equals to minus 16 plus 2t. So that gives us that 16 equals to 2t, and from here we can say t is equals to 16 divided by 2, which is 8. So it stops in 8 seconds. Now we can now substitute the value of 8 to find, does the car go beyond the stop sign before stopping or not, right? So it stops in 8 seconds. So t equals to 8. We can substitute 8 here. So s of 8 is what? Is 62 minus 16t plus t square. We'll substitute 8 here, which is 62 minus 16 times 8 plus 8 square. And that is equal to, let's figure this out. So we have 62 minus 16 times 8 plus 8 square is equal to minus 2. So minus 2 means what? It crossed, correct? So it crossed. Therefore, it crossed the stop sign, right? So earlier it is away. 62 is positive. Do you understand this part? So basically, if this is the stop sign and if the brakes are being applied, the car actually stops here, which is 2 meters beyond the stop line. Do you understand? So that is what it is. And fortunately, if you have a traffic light, so center is around always more than 2 meters away. So that's a safe distance also, right? So I hope that helps you to figure out how to solve such questions. Now let's move on to the last question. Now here is another question where we'll see the minimum distance between two boats. The question here is, a boat leaves a dock at 2 p.m. heading west at 15 kilometers per hour. Another boat heads south at 12 kilometers per hour and reaches the same dock at 3 p.m. When were the boats closest to each other? So let's sketch and understand the scenario. So one boat is leaving, the other one is approaching. So it's leaving towards west and the other one is approaching towards south. Now it is given to us that at 2, let us say the situation is kind of like this. At 2 p.m., let's say that is the point at 2 p.m. Now at 3, the boat reaches the dock. That means the distance here should be how much? 1 hour, the boat traveling south at 12 kilometers. So this distance has to be 12. So this distance total is 12. So in 1 hour, this boat must have gone 15 away, correct? But anyway, in between what happens? Somewhere in between, the two boats could be closest. So let's say they are closest at this situation, at time t. Now during this time t, distance traveled by the boat traveling west, this is west for us, and this is the south, is 15t, since 15 is the velocity or speed of the boat heading west. This distance covered by the other boat is 12t. So in the right triangle which we have, which is right there, let this be the y, distance between the two boats. What is y? Y is square root of these two, correct? So we could write y as equal to square root of square of this distance, which is 15t whole square, plus that distance. It is 12 minus 12t, right? It is 12 minus 12t whole square. Do you get the idea? So this is very important to understand. How do we get the function representing distance between the two boats at any time t, correct? Now, y is a function of t, so we can find derivative with respect to time, and then we'll know minimum distance. So derivative of square root, as you know, is 2 comes in the denominator and everything, so which is 15t whole square plus 12 times, or 12 minus 12t whole square. And in the numerator, we get derivative of each, so it is 2 times 15t times derivative of inside function, which is 15, plus here we get 2 times 12 minus 12t times derivative of inside function, which is minus 12. And for the critical number, this has to be 0. Perfect. That means the numerator is 0, correct? So we can now write the numerator as 0. So we have 2 times, let me rewrite, 2 times 15t times 15 plus we have, you could factor this 12 also out, right? So we have 2 times, let me rewrite this as such only, minus 12 equals to 0. Since this is minus 12, we could take it to the other side. So we'll write this as 2 times 15t times 15 equals to 2 times 12 times, we'll take this 12 also outside, 12 times 1 minus t. Is that okay? Now we can easily simplify. Let's cancel these 2's first. And we can simplify dividing. Okay, no need. We are using calculator, so no need. Otherwise, I would divide this by both by 3 and simplify it a bit. Anyway, it doesn't matter. So let's use calculator. So we have 15 times 15, which is 225. So let me write the left side as 225t equals to 12 times 12 is 144. So we have 144 minus 144t, correct? So let's bring this on the left side. So we get 225t plus 144t equals to 144. And let's add them. So 225 plus 144 is equal to 369. So what is t equals to? So t is equals to 144 divided by 369. We get 144 divided by 369, which is equal to, in decimals, 0.39. So we could write this to 0.4 hours. Is it okay? So we get our time t as 0.4 hours. So t is 0.4 hours, or just multiply by 6t, so which is 6 times 4 is 24 minutes. So after 24 minutes they will be closest. So at that time the time will be 2:24. Is it okay? So at 2:24 they should be closest. So that is how you could do it. Now how do you ensure that this is closest? So the idea here is, what could be the position of the variable? That is what you have to figure it out, right? So the initial condition is that they are, when they started, they're 12 kilometers apart. Is that okay? They're 12 kilometers apart. So what you do here is substitute this value here, correct? And then you can actually figure this out. That is one thing. Second thing is, you could analyze your derivative, right? You could analyze your derivative and then see before this time, that is before 0.3, what is the situation? So you'll find it is negative, and after this it is positive, and therefore it is minimum. How do we know that? If you look at the derivative itself, if I take a value of t which is less than, we know for 0.4 it is 0, right? If I take 0.3 here, 0.3 here, in that case we'll get a value which is on the left side, we'll get a value which is negative. This will be bigger. So you can test for t equals to 0.3. You can test for t equals to 0.5. We know at 0.4 it is 0. So just figure out the derivative, whether it is positive or negative. You will find at this time it is negative, here it is positive, and therefore it is minimum. So we found it by analyzing first derivative. However, I'm leaving this exercise for you to complete. So with that, we have come to an end of this exercise, where I hope you get good practice for your test on application and optimization questions. Feel free to make suggestions, your comments, and if you like and subscribe, that'll be great. All the best.